Welcome and thanks for joining us. My guest today is Mav Turner, the Chief Product and Strategy Officer at Tricentis. Mav, good to have you with us.
Thanks for having me, Tom.
And our topic is software and making software good. So much of the software development going on for and by the government, a lot of the testing focuses on cybersecurity, which is important, but maybe comment on what is sometimes overlooked, and that is the need to constantly test for, does it work? Is it good code? Does it meet your mission?
Right, absolutely. So I think it's been great that, particularly in the last 5 to 10 years, you've seen an increase in security testing as part of the software delivery lifecycle, right? So I think for a while, it was only on how fast can you build applications, how fast can you go, and that shift to say, okay, we need to move fast, but we have to do that in a way that doesn't expose our customers, our business, our citizens to risk. And so that I think is a very good trend. And there's been a lot of money in the industry that's gone to that, a lot of time and energy, and that's great. And the fun part of this conversation is always the balance between functionality and security, meaning you could have it completely shut off, isolated system at the bottom of some bunker, and nobody could use it. And how valuable and functional is that? Well, it's super secure, but not very functional, right? And so when you think about building complex systems that are secure, that are functional, that work in that balance, you really need to make sure that you're not leaving behind that functionality, right? Where are your users at? Is it working for that specific user, that's accessing that from a browser, from whatever location, low bandwidth requirements, particularly if you're trying to reach people that are, that may not be in a high bandwidth area, right? And so when we think about that, obviously, Tricentis is very big on making sure we have that full holistic life cycle in mind, right? So it's not a either or, it's definitely a and. How do we ensure we have the right security tooling in our pipeline? How do we ensure we have the right functional testing in our pipeline, accessibility testing? All of these things have really grown in the last decade from okay, I've built it, I want to ship it. Yes, we've always, had testing as part of the process, but the maturity around what that means has really evolved, I think, over the last 10, 15 years.
And often governments have the imperative, I guess, as any large organization, to eventually, let's again talking about new code here for the moment, integrate that code with existing systems. And that's where problems can sometimes programs get years late because of the integration problem, not the
That's
coding and functionality.
absolutely, yeah, that's absolutely the hardest problem, right? When you say, "Hey, I want to go build this thing from scratch over here," that's usually fairly straightforward, right? I'm not saying it's not work, it's work. We say now I want to connect it to these other systems, right? It was like, well, when were these other systems built? Do we have anybody that understands the interfaces between these systems? And that's where the challenge comes again, not just from a functional perspective, but also from a security perspective, because you have to open up, whether that's opening up a bunch of ports, whether that's authentication between these two systems. There's a lot of risk that gets created when systems interact from a functional perspective and from a security perspective. That's the real challenge when you talk about modernization. It's not just turning on this new shiny app; it's making it work with everything else that's in the environment here.
It's like coming home with a new pickup truck, but it doesn't fit in your garage because it's too low. So
Yeah, it's my biggest problem at home. We've been wanting to get a new car, but it doesn't. What my wife wants doesn't fit.
old garages,
Yeah.
legacy garages. And can you test for future compatibility and test for the interfaces that will be needed? Is that possible to do?
That's a great question, actually. It's really interesting when you think about how much time should you spend documenting a system, right? How much is that system going to change over time? How aware are you of what those interfaces are? One of the standard ways to do this is simply having API documentation. That's usually what you want to use, right? And that's something, again, as you look through how web applications were built kind of in the late 90s, early 2000s, and then how we try to, what best practices are today, is you really don't want these like direct database calls, or you don't want to munge the front end and the back end into one application. You really want that separation. And unfortunately, if you're dealing with a system that was built 10 years ago, more than likely you don't have that clean access API layer. And unfortunately, a lot of systems today actually don't have that great separation either. So if you're in the process of specking out a new system or building an RFP, make sure that you're thinking forward in that regard and thinking about how can, as technology changes over time, because it will, we know that, that you're future-proofing anything new you're building and making that easy and separating out those different service layers.
So that testing might lead you to develop those kinds of interfaces that you need. I mean, some of the government applications are so old they're written to specific instruction sets, on processors. And that
Yeah.
could really get you into trouble, I suppose. Well, I want to look at this from a couple of different angles, this idea of life cycle testing for functionality and compatibility. And there are several types of modernizations and developments that take place. And one of them is modernization, where you're updating legacy code or adding to it. What are the specific challenges in testing in that mode? And we'll get to some of the other modes after this.
Yeah, absolutely. So it's a lot of what you mentioned earlier about, do we have a clear plan of what the system, how the current system operates, what the input outputs are, who has access to connect to these things? Often finding the right person is half the battle here because you need to make sure that you have appropriate levels of access. And again, to continuously tie that security theme into here, we need to make sure that we don't take the easy path and just say, let's just open up full permissions so I can do whatever I want. I need to have, what are the permissions I need? And that can take some time to map that out. Especially if you don't have somebody who has deep code level familiarity with that systems. Now, hopefully you have, mature roles-based access control implemented, and you have very clear APIs documented, and that's great. That's the way to think about it. But typically, that's the big hurdle to modernization is understanding what's in your environment today. And then this may sound obvious, but I think it's super critical. What problem are you trying to solve, right? What service are you trying to deliver? Understanding the user, what information and tools they need to access, for how long do they need to access that data? You really understanding that. And a lot of times people will take this to an extreme. And I'm not personally a huge fan of persona, complexity where you say, what's their favorite type of coffee and favorite book? But you have to understand your user, whether you want to write this weird biography fictional user, or whether you should understand what problems are they trying to solve with this application, and then from there map out what data they're going to need, what systems they'll need access, and that's critical. And I think a lot of times these projects get so complex and big, we lose the user or the person behind who are actually building these systems to serve.
Sure. And from the government standpoint, you hear a lot of practitioners talk about, well, let's give this to users with these low code and no code platforms, which are very effective. But can you encompass them in testing such that, the users are producing all this stuff, but it could break something down the line? And how do you bring that into the testing regime?
Yeah, it's very hard to ensure that you're delivering a quality contained no code or low code. So actually, no code's a little easier, but once you open up that code piece, ensuring quality through that, because they can write whatever they want, right? That is very risky. No code typically has a little bit more boundary conditions, and you can ensure that when you're rolling these kind of building blocks out to your customers, that you test all of those permutations. So no matter how they put them together, you can ensure there's quality. But that requires intentionality on the design side. And that also, when you go full no code, typically will reduce the flexibility that the user has when they're trying to construct these systems. But it's a really important trend, and it's something that we need to continue to do more of because it gives us more flexibility, and we just have to be aware of the pitfalls there. A lot of times the other thing that will happen is people will build these applications and not think of PII or data lifecycle management and all these other things. They'll just think, oh, cool, I've got this tool, I've got this database that I collected. I'm just going to shove it in here, and now this data is flying all the way across the organization, and you've kind of lost control.
But Tricentis can take those types of produced programs into its intake and help you test for that in the low code, no code.
Yeah, absolutely. So one of the things that Tricentis really focuses on and is known for is our concept of kind of continuous enterprise quality. So ensuring that all of these different systems, as they connect to each other, we can ensure that they are working. And we're kind of agnostic to the actual individual technology component. And truly, that's why we think we can really make a difference here. We take a model-driven approach. So you kind of model out how this business process or application is supposed to operate. And then we abstract from the technology layer. So this is a key strategy that really accelerates modernization, because you're not going to lift and shift everything at once. You're usually going to change one of those pieces. Well, if you change one of those pieces and now I have to do a massive amount of re-implementation of my testing, all of a sudden my timelines and my complexity and my risk of the project completing on time really increase. And so that's how we think about kind of modeling out this enterprise application, taking one of these pieces and replacing it, making it easier, or whether it's rolling out new services to your users where they can combine their own. Great, those are just different processes you have to map out.
Right. And I want to talk about new code development. Again, that's always something people test, but same, I guess, principles apply. You have to make sure that it's future proof and that it will actually come into the environment, maybe the infrastructure, and not so much with other applications as in modernization. You maybe have a different connection issue, but that also comes into this lifecycle testing regime.
Yeah, absolutely. When you think about new code, again, that's the fun part. That's the green field. I get to just build it from scratch. Don't have to worry about anything else. Works on my machine is usually what you hear. And then you say, okay, well, what environments is this going to get deployed to? How do I think about whether this can scale appropriately, right? It's one thing in a dev environment when you're doing testing, local testing or testing, with your team. And now it's okay, now I'm going to send 10,000 users at this application. How is it going to scale? Where are the bottlenecks, right? And that performance testing and performance engineering mindset is something we see a lot of teams struggle with when they're building new applications. There's a lot of new architecture and infrastructure you can use to scale that, but frankly, still there's still a skills gap here as well. When you think about even with developers, right? There's so much they have to learn and know that it can be really challenging to think of everything, right?
My guest today is Mav Turner. He is the Chief Product and Strategy Officer at Tricentis. We're going to take a short break. I'm Federal Drive host Tom Temin on Federal Insights Automated Software Testing, sponsored by Tricentis here on Federal News Network. Welcome back to Federal Insights Automated Software Testing, sponsored by Tricentis here on Federal News Network. My guest today is Mav Turner, the Chief Product and Strategy Officer at Tricentis. I'm Federal Drive host Tom Temin. And before the break, we were talking about the testing regimes and the integration issues with modernization of your legacy systems and also with new developments that are greenfield. But increasingly, in the cloud-hosted world, government agencies are using cloud-hosted commercial applications for enterprise different purposes, SAP types of things, Oracle types of things, ERP systems, this kind of thing. And they are often updated, reversioned, patched, whatever, just automatically, which is a great service to the organizations that use them, but it doesn't always result in perfect results, does it?
Yeah, it's the whole trend when we think about how modern technology stacks work, right? We want to take a load off from what we used to have to do as far as running data centers and manually updating software, and that as a service part, the service that's being delivered in that is very valuable, but it does add complexity, and that's where we see a lot of teams and businesses and agencies struggle with keeping up to date because they no longer control that update window, right? Before I could say, okay, once every 3 years, I'm going to do a major system update and I can do this massive complex plan and I could write everything out. And the reality is now, Salesforce updates 3 times a year. Oracle's updating several times a year, in addition to patches that they're pushing out regularly, as does SAP. And any enterprise application that's a SaaS offering is going to update in a cycle. Now, you may be able to do a kind of N-1 scenario where you can be a delayed update, but usually that's months, not years, right? Usually, once you make that move to software as a service, you're really giving up that control of when those updates happen, and you need to be aware of what the vendor schedules are, right? And so that's one part, is understanding what those update schedules are, and then what the dependent components are. And that's where, and a lot of times people would use manual testing, right? They would go through this, like I said, every 3 years or whatever, they would do a manual upgrade, and they just have a lot of people that they would throw at manually testing and making sure things work. We can't do that anymore, right? Because all of these third-party SaaS providers and vendors are updating on their own schedule, and we have to make sure that the services don't break. And that's really where we see a lot of the complexity in these modern environments. And that's where this automated testing approach, this automation, is crucial, because as soon as that update or that preview becomes available, you have to run all your test cases and say, did anything break? Did anything happen that we didn't expect? And can we ensure that our services are going to work as expected to whoever's accessing them?
Right. So you can't turn down those updates because, as you said, it comes automatically from the supplier and it goes across all of their customer base. So what is it you're testing for? I mean, how do you, what do you specifically do at what point in the life cycle of those updates are coming in, or I should say, the schedule of those coming in? How do you know when to launch a test, or can this be automated in some manner?
Yeah, so the most mature teams that we work with are doing continuous testing, meaning every time that there's any kind of daily cycles or if there's a change, they'll push a change in part of their delivery pipeline, will initiate a test to go run through what do we need to test. And then the most mature are able to actually look at specifically what code change, maybe in applications that they've built that have dependencies with these third-party applications and say, okay, this is the part of the application that changed. How do we ensure that we have test coverage and we actually tested that part? And that's really where a lot of customers struggle with, right? They'll come in, they'll build out their automated test, and they'll be really happy with the results. They're able to do this continuous testing, but then they'll realize that something changed that they didn't catch in their process. And so having that quality intelligence view into what code has changed and making sure that that code can't get to production without ensuring that there's proper test coverage. That's again, when you're doing that, you're getting really mature and ensuring that your service delivery isn't interrupted by either your internal teams adding on or building or these third-party SaaS applications getting updated.
Yeah, in some sense, then you really need an inventory, if you will, of those dependencies and what is likely to be affected by coming updates, or updates you know are going to come, you just don't know when, almost like pre-positioning your testing and evaluation such that when the updates do come, you're ready. It's no surprises.
Absolutely. I mean, that's the key thing. And again, mapping out your environment, knowing your third-party dependencies and their schedule, and being intentional about building that up. And if you've got internal teams that are building applications on top of those or dependencies there, understanding what their release schedule is, that going through that process is a lot of work, but it's very valuable because otherwise, if you feel like your teams are constantly firefighting, constantly jumping from issue to issue, getting surprised by things, it's because they need to spend more time on that planning stage. And it's hard, right? I'm not trying to criticize anybody that's struggling with that. And it does take intentional effort to sit down, look at that entire enterprise environment and look at all of these different systems and map them out. That's a very valuable process. And then understanding where your automated coverage is and just making sure you have a plan to improve that, right? But to me, the motto of like continuous improvement is crucial with any customer that I talk to, right? It doesn't matter where you're at in that maturity curve. Let's just try to get a little bit better continuously. If you can build that culture into your operations, you'll have a huge impact as opposed to a lot of times I think we want to come in and flip a switch and overnight make everything better. That's I think unrealistic and that's really hard on the teams versus saying how can we ensure our processes enable us to continuously improve?
And this operational culture that you've outlined, can that also back apply to what a lot of agencies still do, a lot of large organizations still do, and that's simply maintain legacy code? You know, the IRS, when a change in the tax law is enacted, they have to go into their COBOL and into their assembler even and make sure that those business rules get programmed in there. A lot of that type of activity goes on even to this day. And how can that operational culture that you mentioned apply to that activity? Because
Yeah.
same issues of functionality and so on.
Absolutely. It's the same issue. It's just a lot more complex because often all of that knowledge is usually in somebody's head, and usually if there is documentation, it's probably outdated, and a lot of the infrastructure that those systems are running on are hard to maintain. And that's again back to the modernization theme. How can we move these applications forward? Well, you have to have a really great understanding of how those are working. Those, like you said, all the way down to the code level, and how are they going to operate on new infrastructure, right? Sometimes you can kind of lift and shift that quickly and say, great, now we're running it in the cloud instead of our data centers. Great. Now you've added a lot of complexity. And did you provide proper training and staffing around those changes before you've made it? Otherwise, it's going to cause a service issue for sure.
And for that matter, no matter what code you're running, your infrastructure itself has, in many cases, a large component of software. And so infrastructure updates can happen, and that can break things upstream, or, you know, from the basement to the attic, so to speak.
Yeah, and this is where having a tight culture of operations and software delivery and this whole DevOps mindset becomes really critical because if these teams aren't integrated and you're pushing infrastructure changes and they're not aligned and you're not aware on the application layer team, you can be chasing issues for a long time and not realize what happened, what changed in the environment, and ideally, again, back to this maturity curve concept. As you are more fully mature and you have infrastructure as code and you're rolling all of this out, that's the ideal place to be because you can really scale it out. You can know those changes are coming, but that's a hard place to be because it requires very dedicated skill sets, very knowledgeable skill sets, and tight team collaboration. And that's frankly the usually the root of all the issues is the people layer, working together and talking and communicating. And if they can do that, then they have a chance of getting the technology to work.
So would it be accurate to say that having this kind of life cycle testing regime that is comprehensive in the way you've described, that can be really the overarching layer in a maturity system, such that everything is subject to that testing. Therefore, you've got greater reliability and assurance of what it is you're doing.
Yeah, absolutely. I think the when you think about how you take a quality engineering mindset, testing obviously is a key part of it, but really what you're doing is you're ensuring this entire system, this service that you're delivering to your citizens, to users, is it, you know how it works and that you're able to ensure that it's working at all layers as part of your process. That's the real key, right? How can I ensure that all of my processes are working together to deliver a business service that actually operates effectively? And I know if there's issues in my earlier development stage of the environment before it gets to production, right? That's old, and whether you call that testing or whether you're this kind of quality engineering mindset, that's really the goal there and what we're trying to do.
And given that no agency has enough people or enough money, no organization, no development or IT group has the resources it needs, do you think a product and a philosophy that's such that Tricentis brings to this can help people preserve revenue, preserve people, preserve outlays, and somehow abstract the complexity that drives up that cost?
Yeah, I think it's their best shot to be successful here is, how can we use technology to help? I mean, over said, work hard, smarter, not harder here. But how can we make sure we're using the tooling in a way that allows us to meet these objectives? And when we look at scaling, whether that's scaling a technology service, a process, business process within your with your people, you got to think about how am I just adding more people to try to move this thing faster, or at some point, if I can bring in technology in an intelligent way, I can actually redeploy these people into other services. They can go build new things. They can help go after this long backlog of things that as an agency you're trying to accomplish. So you can better use the people. When you're using the people that for things that you can use technology for, then you're never really going to get ahead. You're always going to be underwater. So what we're trying to do and what Tricentis provides is technology that allows you to redeploy those people from manually testing and then this massive burden to other things that can deliver new services and help you burn that backlog down of services you're trying to get out to your users and accomplish those agency objectives. So that mix is really, really important, right?
All right. On that note, I want to thank today's guest. Mav Turner is the Chief Product and Strategy Officer at Tricentis. Thanks for being with us.
Thanks for having me, Tom.
And I'm Federal Drive host Tom Temin. You're listening to Federal News Network. For more on this discussion, please visit federalnewsnetwork.com and search Tricentis.